vertex is the point where two straight lines meet to form an angle. A quadrilateral is a figure which consists out of four lines, and those lines form four angles. So we have here a quadrilateral ABCD because there are 1, 2, 3, 4 vertices and 1, 2, 3, 4 straight lines. Because we already studied triangles, we are going to use the knowledge that we have of triangles to determine some of the properties of quadrilaterals. So what we can do is to draw what we call a diagonal from vertex A to vertex C. So when we connect two vertices by a straight line like this yellow line, we call it a diagonal line. Now for this question, the first thing that we need to do is to calculate with reasons the value of x. Okay, so we see x is part of the triangle ABC, and we know a triangle has 180 degrees. So we can add up all these angles and then solve the value of x. So we know that x plus 96 degrees plus 42 degrees gives us 180 degrees. Our reason: angle sum of triangle equals 180 degrees. Now we have a normal equation because there are equal sign, and we have x and constants. Our strategy to solve an equation is to get the x on the one side and to take the constants to the other side. We already have on the right hand side the 180 degrees. Now the 96 plus the 42, we can add that, which give us 158 degrees. So we can take the 158 degrees across the river, then the equal river, then the positive becomes negative. So we have negative 138 degrees. So now we can solve x because 180 minus 138 degrees will give us 42 degrees. Next we need to classify triangle ABC. Now that we have calculated that x equals 42, we see also that angle ACB B is 42 degrees. So we have two angles that are 42 degrees. So therefore, because we have two angles that are the same, we will also have two side lengths that are the same. So the side opposite angle 42 is side AB, and the side opposite X, which we know is also 42, is BC. So therefore AB and BC have the same length. We also see that we have an angle B that's 96 degrees, which is more than 90 degrees, which therefore is an indication that we work with an obtuse angle. So we can say triangle A B C is an obtuse angled isosceles triangle, because we have two sides with exactly the same length. So what's our reason? Angle ABC is greater than 90 degrees, so that's for the obtuse part. And furthermore, angle BAC equals 42 degrees, which equals BCA, which is also 42 degrees. Thirdly, we need to calculate with reasons the value for y. We see that we have for triangle ACD two lines, or two sides rather, that are equal in length. That means we will also have two angles that are equal in length. So opposite this line DC, we have angle A, or DAC, which is 42 degrees. So we know that the angle that is across the other line that's the same length, namely line AD, which is angle ACD, this angle here, should also be 42 degrees. So we can say angle DCA equals 42 degrees, and our reason will be AD equals DC. The fourth thing that we need to show is we need to classify triangle ADC and explain our answer. Okay, so we already saw for triangle ADC that two of the sides are exactly the same length. So based on that we know it is an isosceles triangle, but we also know that two of the angles are the same size. Therefore it is also a we have two of the angles are the same size. We still need to calculate y. Actually, that was part of number 3. So let's just first complete our calculation of y. Y is actually easy to see what that angle will be, because we already showed in triangle ABC that x is 42 degrees and that this angle is 42 degrees, and we know the sum of the angles of a triangle adds up to 180 degrees. Now we have shown that this angle here, angle DCA, is 42 degrees, which correspond to angle DAC. So just as in triangle ABC, we had two angles that were 42 degrees. In triangle ACD we also have two angles that are 42 degrees. Therefore it can be there's no other possibility other than that angle Y is also 96 degrees, because in any triangle the sum of the angles should add up to 180 degrees. And if 96 was what we needed for this third angle, given two angles of 42, then given two angles of 42 here, we also will need 96 degrees. And our reason would be the angle sum of triangle equals 180 degrees. Okay, so now that we have y, we also know that it is more than 90 degrees. So y equals 96 degrees, which is greater than 90 degrees. Therefore it is a obtuse triangle. So it's obtuse angled. But then also, so our reason would actually be why it's obtuse is that y equals greater than 90 degree. We can also indicate that it is an isosceles triangle, so it's an obtuse angled isosceles triangle, and our reason would be two sides are equal. We know those two sides are ADDC. Lastly, we need to show that if we add up all these angles, we will in fact obtain 360 degrees. So we know the value of x is 42 degrees, and we have 42 degrees here. We also already showed that these angles here, or this angle here, is also 42 degrees, and that y equals 96 degree, b equals 96 degree. So we can now just add up all these angles. So what we know is that A, B, C, D has 96 degrees, but there are two of those angles of 96 degrees, so we can multiply 96 by 2. Then we can also add our 42 degrees, and we know there are 1, 2, 3, 4 42 degree angles. So if we add all of that, we will obtain, let's see, what's 96 times 2? Okay, we know 100 times 2 is 200, but we were short 4. 2 times 4 is 8, so we have to subtract 8 from the 200, so it's 192 degrees. And 40 times 4 gives us 160 degrees. 2 times 4 is 8. 160 plus 8 gives us 168 degrees. Eight plus 2 gives us 10. Carry a 1, 10, 16. Carry the 1, 3. So it adds up to 360 degrees. So we've shown in this specific example all the interior angles add up to 360 degrees. But we can actually prove in general that it will apply for all quadrilaterals. How would we go about showing that? Well, we have two triangles. For any quadrilateral, it is possible to draw two triangles by connecting two vertices with a diagonal. We know a triangle has 180 degrees, so we know the sum of the angles of a triangle adds up to 180 degrees. But if we have two triangles, we can simply multiply the 180 by 2, and that will also give us 360 degrees. So we have just proven in general that any quadrilateral has 360 degrees. We are now going to study the angle properties of the different types of quadrilaterals. First, we are going to focus on the rectangle. For a rectangle, all the angles are 90 degree angles or right angles. A square has the same property as a rectangle in terms of the angle sizes. All four angles are again 90 degrees. So what distinguishes a rectangle and a square from each other is their side lengths. A parallelogram has opposite angles as the same sides. So these yellow marked angles are the same size, and these red marked angles are the same sizes because they are opposite each other. For the kite, the property of a kite in terms of the sides, as we will later study in detail, is that the sides that meet each other to form an angle have the same length. So in fact this side and this side is the same size. This side and this side meet at this angle, so they are again the same size. Now the sizes that are the sides that have different lengths and meet together to form an angle. If we look at those angles, they are opposite each other and they are equal. So it's only these two angles that meet by sides of different lengths that are equal. This angle here and this angle here are not equal. Then we look at our rhombus. The rhombus is exactly the same as the parallelogram in terms of the angle size properties. So what it implies is that both the opposite angles are the same size. So these blue angles are opposite each other, they are the same size. These green angles are opposite each other, so they are the same size. For the trapezium, we know that the one pair of sides run parallel to each other. One of the properties of parallel lines are if a transversal, in other words a line that cuts two parallel lines, if we have a transversal, then the co-interior angles add up to 180 degrees. So in this case, these orange angles add up to 180 degrees. The one might be 140 degrees and the other one 40 degrees. Or the one might be 100 degrees and the other one 80 degrees. The same apply for the blue angles. They are also co-interior angles, so they should add up to 180 degrees. And they are not necessarily the same size, but they add up to 180. So for example, the one might be 30 and the other one 150, and the one might be 20 and the other one 160, and so none of these angles are necessarily the same size, but we have the co-interior angles each that add up to 180 degrees. We are going to work through example 11.3, page 119, to illustrate the theory that we learned about the angle properties and side lengths of quadrilaterals. We are given for number 4 a quadrilateral NOPQ. We're also given all the angles. We can see we have a variable of x and furthermore constants. So if we have one variable and constants, we can form an equation by using the property that the sum of the angles of a quadrilateral adds up to 360 degrees. So we can say therefore that 4x minus 20 degrees plus 80 minus x degrees minus x plus 3x plus 20 degrees plus x degrees equals 360 degrees. Our reason would be angle sum of quadrilateral equals 360 degrees. So now we can solve our equation. Our strategy is on the left hand side we just want the variable x. On the right hand side we want all the constants. So 4x, okay, let's just identify all the x's. So we have 4x, we have negative x, 3x and x. So we can add them all together. Let's imagine instead of the x we have rand. So we have 4 rand. We give away a rand. We have 3 rand. We add another 3 rand. We have 6 rand. We receive another rand. We have 7 rand. So we have 7 rand, but the rand is now the x sign. We can also add all the constants. We have negative 20, we have 80 negative 20 is 60 degrees, plus 20 degrees is 80 degrees. So we have all in all 80 degrees, and that equals 360 degrees. The 80 degrees can now swim across the river, so then it becomes negative 80 degrees. So we have in fact 7x equals 360 degrees negative the 80 degrees. So therefore 7x equals 280 degrees. But we don't want 7x. We only are interested in x. We know a number before a letter means we are multiplying the two. We now need to do the opposite of multiplication, which is division. So we divide the 7x by 7. What we do on the one side, we need to do on the other side because it needs to be in balance. So we have to divide the 280 degrees by 7. And now the 7's cancel, so we simply have x equals 280 divided by 7. 7 goes into 28 4 times, so it is 40 degrees. So therefore x equals 40 degrees. So now that we have calculated that angle x equals 40 degrees, we can calculate each of these angles. So first of all, let's look at the blue angle. So we have 4, but in the place of the x we now have 40 degrees. So we can multiply by 40 degrees. And then we still have to subtract 20 degrees. 4 times 40 give us 160 degrees. We still subtract 20 degrees, which gives us 140 degrees. So we know this angle is 140 degrees. Next we can focus on the green angle. So we have 80 degrees, but now we need to subtract not x, but x is substituted by the value of 40 degrees. 80 minus 40 degrees simply give us 40 degrees. Now we can look at this yellowish orange angle. So we have now 3, but in the place of x we again have the value of 40 degrees. So we can substitute, and then we still have to add the 20 degrees. 3 times 40 is 120 degrees. We still have to add the 20 degrees, and we get 140 degrees if we add 120 and 20 degrees. So we know the yellow one is 140 degrees. And then we can go to the red angle. We know it's simply x, so we substitute x with the 40 degrees, and therefore that angle is 40 degrees. Got to write in the green one, we saw it is also 40 degrees. Okay, but now one of the things that I notice is that 140 degrees plus 40 degrees is 180 degrees. 40 and 140 on this side also gives 180 degrees. That means therefore that these lines are parallel. Because for parallel lines, if we have a transversal, a line that intersect the parallel lines, then the co-interior angles add up to 180 degrees. But we see also 140 plus 40 is 180, and 140 and 140 here equals 180. So in fact, the same applies for these two. They are also parallel. So in fact we have now two pairs of sides that are parallel to each other. Okay, so let us quickly think what kinds of quadrilaterals have four sides, or two pairs of sides rather, that are parallel to each other. Okay, so the first one that I can think of is a rectangle. Okay, but we have a problem. A rectangle doesn't have 90 degree, or a rectangle has 90 degree angles. So it therefore cannot be a rectangle. What's our next possibility? A square also has two pairs of parallel lines, but this can't be a square because a square also has 90 degree angles. Okay, so next, what about the parallelogram? Now, there's no specific indication of a parallelogram in terms of the exact angle size, but what we know is the opposite angles needs to be the same. And guess what? 140 for blue, 140 for yellow, 40 for red, 40 for green. So this is in fact therefore a parallelogram. So we can say this is a parallelogram. based on a combination of the side properties and angle properties. Okay, but there's another possibility. It actually could also be a rhombus if all the sides are equal, but we don't, but in this case all the sides cannot, yeah, in this case we aren't given anything about the lengths of the sides, so therefore in the absence of that information we will settle with the parallelogram as our answer.